वेलकम बॅक फ्रेंड्स. मागच्या व्हिडिओमध्ये आपण पाहिलं होतं की झिरो फोर्स मेंबर कसे आयडेंटिफाय करायचे इन अ रूफ ट्रस मेंबर और पिन जॉइंटेड फ्रेम. हाऊ टू आयडेंटिफाय झिरो फोर्स मेंबर. In this video I will take you through few examples how you can reduce your work or the task of analyzing the roof truss by identifying zero force member by visual observation. जर तुम्ही आधीच सुरुवातीला जर व्हिज्युअल ऑब्झर्वेशनद्वारे झिरो फोर्स मेंबर्स आयडेंटिफाय करू शकला तर तुमचं काम कसं कमी होऊ शकतं, दॅट वी विल सी इन दिस व्हिडिओ. In this roof truss, the first example, if you first observe this, now this joint F, if you see joint F, so I will just draw this by visual observation. If you follow the guidelines in previous lecture, at this joint F there is no external load acting. There is no external load acting. In that case, these two will carry same load, whereas this member, that is member force along FD, will be zero force. So this member force F along FD will be zero. Now you can just cross check this whether it is going to be zero or not by usual equilibrium equations only. So this is say horizontal datum, so these two angles will be similar, theta theta. You can just go for simplifying the things. You can apply summation Fx summation Fy equal to 0 to these forces, and after going for resolution you will come across these two member forces are 0, that is force along Fb and force along Fa. These are similar and this FFD comes out to be 0. Just to avoid that calculation by visual observation itself, you can identify this FD. Now similar to joint F, joint G is also of same nature, exactly in reverse direction. At G again there is no external load acting, and these two member force will be similar, magnitude will be same for force along GB and for force along GC. The magnitude will be same, and at the same time force along G will be going to 0. So this force G is 0. Right? Now once these two member forces are 0, now then you can come to joint D. Now if you look at joint D now, what is happening? DF has become already 0. So there remains this force along DB, force along DB, force along DA and force along D. So as there is no external load acting at joint D, once again this member force will be 0. Now it is very simple here. Once you directly apply summation Fy equal to 0, you will get force along DB equal to 0. Now in this inclined members, you will have to write down both equilibrium equation for joint F as well as joint G. You will apply summation Fx equal to 0 as well as summation Fy equal to 0, and then you will be landing up at this value Fg equal to 0 and Ffd equal to 0. But at joint D, directly if you apply summation Fy equal to 0, this Fdb is going to be 0. Similar to that, if you consider joint E now, at E, that EZ is already 0, then force along EB, force along EB, then force along ED and force along EC. Again if you apply summation Fy equal to 0, this has to become 0. Means what? All these four member forces are straight away 0. So you need not to analyze joint D, analyze joint E. So straight away with 3 joints only, this entire truss can be analyzed. So this is how you can reduce your work of truss analysis by identifying zero force members of a given frame by just visual observation. So you should practice it, and once you master this observation technique, so you are going to reduce the work of truss analysis. Now this is second example. Now in this second example, you can see there is support at A, support at B, and this frame is like this. At F, if you observe, there is no force acting, external force I'm talking about, external force acting at F is 0, or there is no external force acting at F. If I consider this joint F and draw FBD for that, so there is force along FA and there is force along FC. And if I apply summation Fy equal to 0, what is going to happen? FFC is going to be 0. If I apply summation Fy equal to 0, the force along Fc is going to be 0 because there is no external force acting. So this member force will be 0. And next, if I apply summation Fx equal to 0, this FFA is going to be 0. So these two member forces straight away you will be getting removed. So this is how, if you start observing, you will readily calculate magnitude of member forces. Few of the, of course, all entire truss many times it won't be 0. So when you are appearing for time bound examinations where time is less and you have to go for analysis within very less time, in that case such techniques will be highly useful. In this next truss, if you see now here, this H joint, if you consider, so this is T joint and no external load is acting at H. So means what? If I apply summation Fy equal to 0, straight away this force is going to be 0. So this is going to be 0 force. Next, if I go to joint G, this is inverted T joint. Joint G is inverted T joint. No external load again at joint. And this force along GC, that you will get readily 0 by applying summation Fy equal to 0. Now similar to this, this E joint is there. At joint E also there is no load acting. So if you apply summation Fy equal to 0 again, so this member force EB becomes 0. So this is how you have to just keep observing, and once you master this technique of visual observation, you will be readily in a position to identify zero force members of that particular frame. You see this now. So at the very first instance, if you see it, you might feel that it will require very much time, it is very difficult to analyze, blah blah. But if you start identifying zero force members of this truss, you will be very glad to know that yeah, it can be solved in very few minutes, right? So we'll start now, starting with this joint E. At joint E, you see, so there is no external load acting, and this member force has to be 0. So you can mark it as 0. Now similar to E joint, there is F joint. Again this member will be 0, right? Now when I move to joint M, so this EM has already become 0 and there is only one member again. So force along this member will be 0. So this becomes 0 force member. If I go to joint H, this is inverted T joint and there is no external force acting at H. So what is going to happen? This member for DH has to be 0, friends. Right? I hope you are following the things. So first we started with joint E. So in joint E, so as there is no external load acting here, so this member force will be 0. We mark that as 0 here. Then we move to joint EM. So this member force, as it is 0, you need not to show it. So force along EMD has become 0 here. So that we have marked. Then we have moved to joint H. Then this has become 0. Now friends, if you observe this joint D, what has happened to D? Now there is only one member force unknown, that is force along DI. But as there is no external load acting at D, again this will become 0. Right? So how many members on left hand side will become 0? 4 members. Right? Then I move to joint J. So at J again this is inverted T joint, this will become 0. Now similar to joint M, here you can do it for joint N. So as this NF has become 0 force member and there is no external load acting at N, this member force NG will be 0. Then I will go to joint L. At joint L, no external load, so this member force GL will be 0. Then I will move to this G. If I move to this G, what has become? This GK will become 0. Now if I go to this I, right? If I go to joint I, again it's like this. So no external load acting at I. If I apply summation Fy equal to 0, this member force I to M becomes 0. If I move to joint K, this member force Kn becomes 0. So only unknown what remaining is joint B. If you analyze this joint B, that will be very easy thing. So EMB also will become 0 because if you consider joint M, so this will 0. If you consider joint N, this NB. So what is remaining now? Member force AD, member force AH, and at B, BE and BF. So once you find out these values, your entire truss you can solve. CG, CL, only this joint A, C and B needs to be analyzed, and that will end up your entire truss analysis. So this is possible only when you are in a position to identify zero force members. If you can readily define these zero force members, so nothing more easy in that. So this is the importance of identifying zero force members. So once you master this technique of visual observation and how to identify zero force members, your truss analysis will become really very easy task. So with this example, I stop in this video. If you have any doubts or queries related to this, you can very well contact me at any time. So with this, I stop here. Thank you very much.